Skye and I'm a competitive weightlifter. My invention is the weight plate loader, and I made it so that weight plates can be loaded automatically. Even at the Olympics today, they're loading all the plates by hand, which is very tiring. I even know an athlete who represented Australia at the Commonwealth Games, and he injured his back from loading plates during training. This invention is to solve all these problems. This is how you use the weight plate loader. First, you load the barbell onto the holder, like this. And then on the touchscreen, you select, there are lots of weight options, and you just select which weight you need. For example, if I'm lifting 45 kilos, I'll click the 45 button, and then the machine will automatically start calculating which weight plates are needed, and it'll start loading them. All the components that you can see moving on the weight plate loader are driven by stepper motors. Stepper motors are very precise and have higher torque than other motors. They are ideal for this task because everything on the weight plate loader needs to line up perfectly for it to work. I also chose them because the speed, direction, and rotation of the motor can be controlled. Each motor needs a driver to control the electromagnets in it that cause the motor shaft to rotate. Now that the bar is loaded, the user can use it for their exercise. To unload the barbell, just roll it back on, and then click the unload button up here, and it'll automatically unload them. The whole weight plate loader is controlled with an Arduino to move the parts. The unloading it's doing now is just the reverse of the loading program. Each motor is wired to the Arduino. The Arduino sends pulses to the motor drivers, which can convert the pulses into signals that the motor can use to turn the motor shaft. This is the XAxis. It's where the weight plates slide left and right to align with the barbell. The weight plates slide on bearings along steel shafts. This axis runs along a trapezoidal screw, which is connected and driven by a motor on the right. The screw is not only a simple machine that makes the job of pushing the weight plates easier, but also converts the rotational motion of the motor into a linear motion for the weight plates to slide left and right, as you can see. This is the Y-axis that drives the weight plates forward onto the barbell and runs on a rack and pinion, which is a gear that rolls on a track with teeth, driven by a motor. The axis also consists of the MDF base, which has a track engraved in it. This track is for the wheels, located in each corner of the frame, and takes most of the weight so the load is spread out. This is the ZAxis, which is a barbell lifter. It's a lever that makes the task of lifting the barbell easier. It has a mechanical advantage of 1.8. It's driven up and down by a motor connected to the ball screw on the right. The screw is a simple machine as well, and makes the job of lifting 85 kilos easier. The screw has a mechanical advantage of 10, meaning it requires 10 times less effort to lift the barbell. The weight plate loader is made from many different materials, depending on what the task of the part is. For example, part of this XAxis frame is CNC cut acrylic because I needed the holes to be placed in certain positions for screws to connect. A lot of the machine is made of aluminium extrusion because it's light and easy to put together with other pieces. It also has slots, meaning the pieces attached could be adjustable, which is very important for this machine, since it was a prototype and needed a lot of experimentation and testing. Although steel is very strong, I couldn't use it for the whole thing, as each hole needs to be drilled manually, whereas the extrusion already had slots I could use to move pieces.